In today's video, we will look at a technique of integration known as change of variables, or also more commonly known as U substitution. Now, this is a very special type of function for this technique to apply, and we will look at that type of function in this video, as well as look at how to use the change of variable technique. For this technique, let's say that g prime of x is continuous over an interval I. We will say f of x is also continuous over I. I'm sorry, not over I, over the corresponding range of g. And we're going to say that big F of x is an antiderivative of little f of x. Now, what we want to do is we're looking at this antiderivative of f of g of x times g prime of x. So notice that if we take the derivative of big F of g of x, this is a chain rule. This would give us big F prime of g of x times g prime of x. But since big F is an antiderivative, big F prime is just little f. So we have little f of g of x times g prime of x. That means that this antiderivative up here is equal to big F of g of x, and obviously we can't forget our constant of integration. So the change of variable would be let u equal g of x, where g prime of x is continuous over an interval, let's say I, and let little f of x be continuous over the corresponding range of g. Then the u sub is this. Antiderivative f of g of x times g prime of x is the antiderivative f of u du. So this is our technique, and then this makes the antiderivative f of u one that we can evaluate using the techniques from the previous video. And now some examples. First, let's take a look at the antiderivative of 6x times 3x squared plus 4 all squared. Now what we have to do here is look, okay, let u be this 3x squared plus 4, because notice that du here is 6x times dx, right? Well, here is 6x, here's dx. So what this now becomes is the integral of u squared du. What we know that is u cubed over 3 plus a constant. Now just replace u with what we said it equals, which in this case is 3x squared plus 4. So our antiderivative is 3x squared plus 4 all cubed over 3 plus a constant of integration. Next, let's take a look at the antiderivative of z times the square root of z squared minus 5. Well, we would say that u is the z squared minus 5. And then our du would be 2z dz. Well, here's a z, here's a dz. We are missing a 2. So let's multiply by 2. But we can't just multiply by 2 unless we also divide by 2. This antiderivative now becomes 1/2 the antiderivative square root of u du, 1/2 the antiderivative of u to the 1/2 power du. That'll be 1/2 times u to the 3/2 divided by 3/2 plus a constant. That's 1/2 times 2/3 u to the 3/2, which is 1/3 u to the 3/2 plus a constant. This gives us the quantity of z squared minus 5 to the 3/2 power divided by 3 plus a constant of integration. And finally, let's look at the antiderivative x over the square root of x minus 1. Now here, we would say let u be x minus 1. This means that x is u plus 1. Now the reason we have to do this is, look, this du is simply dx. Right, and that leaves us a problem of we still have that x up there to worry about. And that's why we say it's x is u plus 1. This then becomes the antiderivative of u plus 1 over square root of u. We can now take each term of the numerator and divide it by the denominator, since the denominator is a monomial. So we have u over root u, which is square root of u. And I'm actually going to write that as a power instead. So u to the 1/2. Then it'll be plus u to the minus 1/2 du. That'll be 2/3 u to the 3/2 plus 2u to the 1/2. And u was x minus 1, so we get 2/3 x minus 1 to the 3/2 plus 2 times x minus 1 to the 1/2 plus our constant. That concludes this video on change of variables. The trick here is you have to choose the right function to replace with u. That is always the key. What you want to do is it's typically a function that you don't know how to find the antiderivative of, right? For this first one we said, oh look, it's a 3x squared plus 4 all squared. Well, you could do algebra and expand that out and then distribute the 6x through. That's too much work. So we'd say, okay, well then we know how to do u squared, so just let u be that 3x squared plus 4. Here, square root of z squared minus 5. There's no algebraic simplification there, but we know how to do u to the 1/2, so we say u is z squared minus 5. And the same thing with this last one, square root of x minus 1. Don't know how to do that, but we do know how to do 1 over the square root of u. So u should be x minus 1. In the next video, we will finally introduce the most important result of all of calculus, known as the fundamental theorem of calculus, which will relate the antiderivative to the definite integral. I will see you all in the next video.